Hello viewers, Wagdaruna taking you through the story of A-level pure mathematics. And in this video we are going to go through the marking guide for Senior 5 Math Per 1 end of term 1 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are the set of past papers we hope to upload in this Solid. And I still remind you of the books you'll need in this level. So there is in math, principal math, there are 4 books. There is Math Per 1 notes, Math Per 2 notes, Topical Question Bank, and Termly past papers with marking guides. Subsidiary math, it is only one book which has all notes, Termly past papers, and unit past papers with their marking guides. Physics, there are still 4 books: Physics Per 1 notes, Physics Per 2 notes, Topical Question Bank, and its solutions. So for any of these copies, contact the author on this contact. So now we shall go to the questions and see what the examiner wanted you to write. So the paper consists of 2 sections, section A and section B. Section A has 40 marks, meaning it has 8 questions. Question 1 says, solve the simultaneous equations. So in your O-level, you did some simultaneous equations, but they were for 2 unknowns. For example, they could say P and Q equal to this. But in A-level, they can also add a 3rd unknown. Or they can give you 2 unknowns, but with a certain power. So and we shall look at all those in this paper. So let's start with this one, solve this equation. So what you need to do, you choose one unknown to eliminate first, so that you remain with 2 equations with 2 unknowns. Then you use the knowledge for O-level. So I'll first label them. This will be equation 1, equation 2, equation 3. Because here in A-level, the way you present your work must be self-explanatory. So you must tell us, you must communicate what you are doing. So when I get equation 1 times 2, I'm applying 2 throughout this equation 1 and I add it to equation 2. I realize that I'm going to eliminate Q. So let's see how that is done. So when I add this, I'll come up with this. This goes away. This come up with this. This come up with this. So I've managed to eliminate Q, and I've got one equation, but I still need 2 equations with 2 unknowns. So let me also go to equation 1 and equation 3. Equation 1, there is 2. Here there is 8. Meaning to get this 8, I must multiply this by 4. That is why you are seeing here a 4. So when I do that, I'll come up with this. So add this to get this. This cancels. Add this to get this. Add this to get that. So now we have managed to get 2 equations with 2 unknowns, which are somewhat similar to the ones for O-level. And managing to come up with those 2 equations with 2 unknowns, that is 1 mark. Then next is to deal with these 2 equations and see how we can get the values of P and R. So I'll come here and say that multiply equation 4 by 9 and multiply equation 5 by 4. Then you subtract the 2. When I subtract this minus this is 0, this minus this is that, this minus this is that. So at the end, R is equal to 1. Then from equation 4, I'll substitute for R and get the value of P. Then from there, I can go back to either equation 1 or equation 2 or equation 3. So if I choose equation 1, I'll come and substitute for P and for R and remain with Q as the only unknown. Simplify and make Q the subject. And that's what they wanted. So I managed to get the value of R, P, and Q. And that's what they wanted. Okay. Then question 2 says solve the simultaneous equations, but this time there is a power somewhere. So first thing, here the basis is the method of substitution. In question 1 we use the method of elimination. Now we are going to use the method of substitution, where we make one unknown the subject in one equation and substitute it in equation 2. So you have chosen to make y the subject. Now I'm going to substitute where there is y. And when I do that, I'll come up with this. Where there is y, I'll put there 4 over x. So this power works on both numerator and denominator. That's why you see here 48. 48 comes from 3 times 16, or 3 times 4 squared, which is this, over x squared. Then multiply throughout by x squared, you'll come up with that. Rearrange to get. Now here it is an indirect quadratic because this is x power 4 and this is x squared. So you can say, what if I make w be equal to x squared? What will happen? It means this will become 2w squared and this will become 22w's, which is a quadratic. So how do you solve that? You can use the quadratic formula. By this time, this will be x squared. Or you can set w in case you say let w be equal to x squared. So I'll come up with two values of x squared, get the square root, it will be plus or minus. Then I'll come and get for the corresponding value of y. When x is this, or this is the same as root 8. So when x is that, I'll come up with this, which is this. Then when x is this, I'll come up with that. So that's how they wanted you to solve simultaneously. Solving simultaneously means you get values of x and also values of y, which satisfy both equations at a certain point. Okay, so the word mobile here means a mark can be given on this substitution or on this substitution. Because sometimes the students may substitute well here and wrongly here. It means you still get 1 mark here, but this A will not be good because this A, all these have to be correct. Then question 3 says, express this in the form this, and hence find the value of P when the minimum value of y is equal to 0. So I expect that by now you are conversant with what we call completing squares, because it will be used. But we can recall it somewhere, where we say that x squared, I think realize that here the coefficient of x squared is 1. Always remember that coefficient of x squared must be 1 before you complete squares. So if I have such, to complete squares, it means I'll say x plus half of this coefficient of x, everything squared, minus the square of this will be equal to that. So that is what they mean by completing squares. You first divide this by 2, put it here, then again square it, bring it here. So now that I'm given this, what I'm going to do is to first make this coefficient positive 1 by factorizing out 3p. Now it is positive 1. Then I can follow this rule whereby I say half of this is what? It is a third. So I'll come and say x plus a third, everything squared, minus a third squared. Then I can simplify. And that's what they wanted. So it is already in this form where a is 3p, b is a third, and c is the whole of this. But they told us something about the hence part. They said find the value of p when the minimum value of y is equal to 0. So minimum value of this occurs when the squared term is equal to 0. Minimum value occurs when the squared term is equal to 0. So here I'll come and replace the square term with 0 to get the minimum. But I remember I was told minimum value of y is 0. So I'll come and substitute here 0. And then make p the subject. And that's what they wanted. So that's how marks would be awarded. Then question 4 came from indices. It says solve the equation that. So you already know that this one can be written as this. Rule of indices. Then after that I can now let y be equal to 2 to the power x and substitute for y. You realize that I've got a quadratic equation which can be solved using quadratic formula to get two values of y. But that's not the answer because the question wants you to solve for x. So I'll still have to remember that y is equal to 2 to the power x. So come and substitute where there is y, put there 2 to the power x. Here by the rules of indices, with same base, it means x is equal to 1. But here there's no way you can do that, so the base is to introduce in logarithms. So here the x will be equal to logarithm of 1.5 divided by logarithm of 2, everything to the base 10. You'll come up with this. So here we have rounded off to 4 decimal places. And basically that's what they wanted. Okay. So here we have used the B's instead of A1 because an A accuracy cannot come from a bonus. It comes from a method. Then question 5 came from SADS. So they want you to simplify. Simplifying means you rationalize the denominator. So in other words, there should be no SAD in the denominator. So the first thing to do is to multiply by the innocent expression. You realize that these are 3. In O level there could be just 2 terms, but now what you do, you first pair 2 of them. Then you multiply by a term whereby this sign changes. I think you realize that it is changing. It was plus here, now it is minus, and here it is minus. Then you expand. Expanding means this with this to give you that, this with this to give you this, this with this to give you this. For the denominator it is easier because it will be difference of 2 squares. So this squared minus this squared. Okay. Then we simplify. 12 is the same as 4 times 3, so square root of 4 is 2, that's why you see here 2. 18 is the same as 9 times 2, so square root of 9 is 3, that's why you see here 3. Then here you have to again expand this. How? Square this, then twice the product of the 2 entries, which is that. So after that we shall now, the numerator, there's nothing you can do, but the denominator we can calculate like terms. So this plus this is 7 minus 3 is 4, that's why you say 4 here. Okay. Somehow you have reduced because there were 3 SADs, but now we have 1 SAD. So we still have to rationalize. So we are going to multiply by an innocent expression. This was, the sign changes, it was minus here, it becomes plus here and also here. Then we expand. So expanding, you need to be patient. For we're going to first multiply 4 through this to get these 3 terms. Then again multiply 2 root 10 through this to get these other terms. Then for the denominator, it is difference of 2 squares. 4 squared, 16. Then this squared, it is 40. So let's first see marks for this slide. So there's a mark for rationalizing, expanding and simplifying, rationalizing again, expanding. So you simplify again until we cannot simplify any further, and that's what they wanted. Then question 6 came from trigonometry. It says solve the equation this for values of x ranging from 0 to 360. So first you need to realize that we have to express in terms of one ratio. So here the base is sine because we already have sine here which doesn't have a power, so you have to change this in terms of sine. We already know that sine squared x plus cos squared x is equal to 1, meaning that cos squared x is the same as 1 minus sine squared x. Then we open brackets and collect like terms to get a quadratic. That is a quadratic in sine x, meaning I can still use quadratic formula to get the two values of sine x. But the question wants you to solve for x, so you have to get for when sine x is equal to this and when sine x is equal to this, what are the angles? So here we need to use quadrants. So here I realize that sine is positive, meaning that you are going to get your calculator and first press arcsine or inverse sine 0.7430. What do you get? So you'll get 47.76. So angles here angles are written to 2 decimal places. That's why you're seeing me writing only 2 decimal places. Now the angle you get is put on the horizontal line. Remember, sine is positive in the first and second quadrant. That's why I'm drawing this and this. Then after that, you put the angle starting from the horizontal line to meet that line. Okay, then we can now generate our angles. They said angles range from 0 to 360. So the first angle will be this, and the second angle will be from here up to here. So that was for this. Now we shall go to when sine is negative. Sine is negative in the third and fourth quadrant. So what you're going to do, you realize we have this. So what you're going to do, you first ignore this. Then you press arcsine of 0.5403. You'll come up with 32.70 when you round off to 2 decimal places. So that angle must be put, like I said, on the horizontal line, there and there. Then from there, remember that positive angles are measured from here going in an anti-clockwise direction. That will be the first angle, and the second angle will be from here up to here. So when you do some algebra, you come up with that list of angles. The first one is from here up to here. Okay. The second one, remember they have to be written. Okay. This second one is from here up to here. So get your calculator and press 180 minus 47.76. You come up with this angle. Then this one is from here up to here. So get your calculator and press 180 plus 32.70. Then this one is from here all the way up to here. So get your calculator and press 360 minus 32.70. You come up with this. Then you can list them in ascending order, all of them, and that's what they wanted. So first was for seeing this identity used quadratic equation, solving a1 for these two values, another a1 for these two values. So then realize that this a1 is coming from an m1. If here it was b, then here it wouldn't be, it can't be a. Then question 7, solve this for values of theta ranging from 0 to 360. So yes, still we can get a quadratic, we can express everything in terms of tan by changing this, because cot theta is 1 over tan. So come and substitute it there, then multiply throughout by tan theta to get a quadratic in tan. So you can use quadratic formula to get the two values of tan. So the good thing, both are positive and tan is positive in the first and third quadrant. So when I press arctan 6, I'll come up with this value 80.54. So I put it there and also here. Then arctan 1, I'll come up with 45. So I'll put it here and here. Okay, then I'll get the angles. For these ones, the first angle is from here up to here. The second angle is from here up to here, which is 180 plus 80.54 to get this. Then for this one, the first angle is this. The second angle is from here to here, which is 180 plus 45 to give you this. Then you can list them in ascending order, and that's what they wanted. So here the first method was for seeing you changing this to this, then a quadratic formula, solving. This A1 is for this set of angles, this one is for this set of angles. Then question 8 says solve the equation this given that theta ranges from negative 180 to positive 180. So that is what we are given. We have to use compound angle identity to expand this to give you sine theta cos 30 plus cos theta sine 30. Then we divide through by cos. When I divide through by cos theta, this over cos theta is 1. This over cos theta is tan. This over cos theta is 1. Then from there, remember that cos 30 is root 3 over 2, sine 30 is a half. Then I rearrange to make tan theta the subject. Then I can get the value of theta. So yeah, tan is positive, so it is in the first and third quadrant. So press your calculator, arctan 1 over root 3, you get 30, which you put here and here. So the angle you put must start from a horizontal line. Always remember that. Then the first angle will be from here up to here. The second angle is now here. Do you see this range? Okay. Previously we would say that the second angle will be goes from here up to here. But that angle will be beyond positive 180. So what do you do? You change it to become negative. How? Because positive angles you start from here and go anti-clockwise. Negative you start from the horizontal and go clockwise. So if this is bigger than 180, then you have to change and make it negative by saying from here up to here, which will be negative of open brackets 180, okay, minus 30. What do you get? You'll get negative 150. That's why it's negative 150 there. And basically that's what they wanted. So seeing this compound angle correctly stated from and it's available in the logbook, dividing through by cos, so here should be cos theta. Then substituting for sine 30 and cos 30, simplifying, and here both angles correct. That was section A. Now we shall go to section B. So section B had many questions, but you could attempt any 3. But a standard paper a student will be needed to attempt any 5. So question 9 says part A, solve the equation this, and part B, okay, let's start with part A. So part A, you will realize something. We wanted you to notice that this is the same as this. So what do? You have to let. So I said you to come here and say that let y be equal to that. Then I can substitute to make it a little simpler. Then multiply throughout by y to get a quadratic in y, which can be solved using quadratic formula. Then you'll get two values of y. But remember, the equation wants the values of x, so for each value of y, we shall get the corresponding values of x. So you shall come here and say that when y is equal to 35, then means that this is equal to 35, which can give you a quadratic formula and you can solve it to get this. So this is a quadratic equation. You can solve using the quadratic formula to get the two values of x. Then also when y is -1, it means that the whole of this is -1. Rearrange to get a quadratic equation. Use the quadratic formula to get the value of x. Okay, so basically that's what they wanted in part A. There was a mark to change variable, a mark to solve, and a mark to get the two values of y, mark to solve, both values of x, value of x. That was part A. Now we shall go to part B. Part B says use the substitution this to solve the equation this. Now this is what they call symmetric equation. I want you to notice something. This quotient is 10 and this is also 10. Okay. This quotient is -37 and this is also -37. And there's a center part. So that is what we call symmetric equations. How do you deal with them? Let's see how. So first of all, when I have that, I need to square it. So when I square this, I'll come up with this squared, so I expand it, this squared, then twice the product of these two to give you that, simplify to get that. That means that x squared plus 1 over x squared is equal to y squared minus 2. Knowing that, we can now go to the given equation, and because it is symmetrical, the first thing to do is to rearrange so that the similar coefficients are next to each other. Then you divide throughout by x squared. Then you factorize. So I think you realize that I've come up with this, which is here, and also I've come up with this, which is here, meaning I can substitute. So when I substitute, I come up with that, which is a little simpler now. Open brackets and collect like terms to get a quadratic equation in y. Solve it using quadratic formula and get the two values of y. So for each value of y, I must get the corresponding values of x. So when y is that, it implies that x plus 1 over x is equal to 5 over 2. Then solve it. Multiply by the LCM. LCM is 2x. You come up with this, which is a quadratic equation. So I need to solve it using quadratic formula to get the two values of x. Okay. What about when y is this? So do the same, substitute, and multiply by the LCM, which is 5x, to get a quadratic equation in x. Then solve it. You realize that x is undefined. Why is it undefined? You must have covered something called a discriminant. If that term is less than 0, there will be no real root. So let's see. -6 squared is 36. Okay. 4 times a, which is 5, times c, which is 5. So that is 100. So 36 minus 100 is negative, so x is undefined. So there was a mark for changing variable from x to y, solving both values of y, solving, so this was mobile, both values of x, and here identifying that x is undefined. That was question 9. Now we shall go to question 10. Part A says, solve the equation this. Okay. So the first thing to do is to rearrange. Take one this side to come up with this. Then you can square both terms, both sides, and expand. Expand this, I'll come up with this. Expand this, I'll come up with this. Then from there, I can collect like terms. To get that, there is still a square root, so I still need to square both sides so that the square root goes away. Then I can rearrange to get my quadratic equation, which can be solved. So there is a mark for this expanding, squaring both sides and expanding, squaring both sides and expanding. Now I need to solve that quadratic, and I'll come up with two values of x. But I'll need to verify, because it is true we have got these values, but do both values satisfy the given expression, which is this, or not? So I'll treat each value separately. Let me start with 5. So where there is x, I'll put there 5 and see what I get. You realize that I come up with 1 equal to 1, which is true. So that one satisfies. What about the second one? So come and substitute where there is x, put there that, and then simplify. You come up with -1 equal to 1. So that means that this is false. Therefore, x is not this, but it is that. Now, this step of verifying is also necessary in such equations. So if you don't verify, it means that 2 marks will be gone. Now let's go to part B. Part B, let me first see it. So part B says, a man wishes to fence off his newly acquired land for constructing his house. Okay. He has been advised to preserve 5,000 meters squared of a rectangular piece of land that is neighboring an existing straight wall for this purpose. Okay. Determine the minimum length of wire fencing he may need for this purpose. Now this is about minimizing and maximizing. Someday when you cover differentiation, you realize there is a different method for minimizing and maximizing. But for now, the only method you have covered is the one for completing squares. So that is what you are going to use in this video. But if you want the second method, it will be learned after some time. That will be now in second term. So let x and y be the dimensions of the rectangular piece of land, and p be the length of the wire, or the length of the wire. So we shall come and make a small sketch. We have an existing wall, and this will be the wire. So when I put this shape of the wire, I'll have completed the rectangular piece of land. So area, we are given area, so area is length times width, so x times y is that, meaning that I can make y in terms of x, which is equation 1. Then for the length of the wire, we shall call it p, which is 2, because remember here there is x also, so x plus y plus x, you come up with 2x plus y. But y is this, so where there is x, substitute for that. Then I can get the LCM, then I can cross multiply to come up with the quadratic. The reason why I'm doing so is because I'm using the method of completing squares. So in that method, I must generate a quadratic equation. Otherwise, there would be no need to cross multiply if I was using the second method for differentiation, but that will be learned in second term. So when I cross multiply, I get a quadratic equation. I have to rearrange, then I can complete squares. So to complete squares, remember I told you this coefficient must be positive 1. So divide throughout by 2 to come up with this. And now that the coefficient is positive 1, I can complete squares. Half of this is what? Is p over 4. That's why you see p over 4 there. And also p over 4 squared there. So there was a mark for this, a mark for this, a mark for this, a mark for complete squares. So I can simplify. So for minimum length, that squared term must always be 0. Therefore, substitute for that to come up with 0 minus this plus that. I think I have only one unknown which can be made the subject, and that's what they wanted. Therefore, the minimum length of the wire will be 200 meters. Okay, then question 11 is from trigonometry. I'm saying trigonometry part A. So given that this is equal to this, show that tan theta is equal to that. So yeah, in the question which was there in the exam, it was plus root 6, but the proof could not come out. So this is the corrected part. I've just edited it. So the first thing to do is to remember the compound angle identity. So I have to expand. After expanding, I can. So this is this, expand this to get this, expand this to get that. Then you can now substitute sin 30 is a half, cos 30 is root 3 over 2. Then here, sin cos 120 is negative a half, and sin 120 is positive root 3 over 2. Then you realize that these two can cancel throughout to remain with this, this with this, then 2 with this to give you that, 2 with this to give you this. They want tan, so I'm going to divide throughout by, I can either choose to divide throughout or I can rearrange. When I collect like terms, this can go this side to become 3 cos theta. This can go this side to become negative root 3 sin theta. Then divide both sides by cos to come up with this, and sin over cos is tan. So that's what they wanted. Okay. Then part B, let's go to part B. Part B says, prove that the angle theta between the lines, this and this, is given by the expression this, and hence find the angle between the lines this and that. Okay, so first of all, you need to remember that gradient is the same as tan and angle. So I shall come here and say for this line, rearrange it to be in the form of y equal to mx plus c. So here the gradient is negative a over b. And for this line still, rearrange it, and realize the gradient is negative p over q. So I have both gradients. I can now quote the formula from the logbook. That is the formula. Then I substitute for m1, m2, m1, m2. The next is now algebra to simplify. So this with this gives you positive. That's why you see plus here. And this times this is positive. That's why you see plus here. So this times that is AP. This times this is that. Then here I'm going to get LCM to give you this, get LCM to give you that. You realize that this and this are the same, so they can cancel to remain with only this as the numerator and this as denominator. Okay, but the proof, you realize that this is BP minus HU. But if you look at the proof, let me first see. The proof is HU minus BP. The denominator is okay, but this one was HU minus BP. So how do we get that? Is for that reason that they put those magnitude signs in the logbook. You will see them there. So I'll factorize out a negative 1 to come up with this. Then I remember that when they are magnitude sign, it means what is negative becomes positive. So I'll remove the magnitude sign and remain with the positive part. And that's what they wanted in that part. But there was a hence part. Maybe if I could do that, let's see the allocation of marks here. Okay, so now let's see the hence part. For the hence part, they said find the angle between the lines this and that. Okay, so shall come here, and when they say hence, it means you start from where you stopped. So we stopped here, we have to start from there. Therefore, comparing this with this, I'll get values of A, B, and C. Also comparing this with this, I'll get values of P, Q, and R. Then I'll quote the formula I proved and substitute for A for Q, for B for P, for B for Q, for A for P. Then I can now use a calculator to get arctan, which is 75. And that's what they wanted. That was question 11. Now question 12. It says, part A, find the greatest value of this, and hence determine the turning point of the graph that. So I think let's begin with that. Like I told you, there are two methods of getting turning points, or maximum and minimum. But for now, the only method we know is the one method of completing squares. So that's what we shall use. So here, this is the equation. The first thing to do is to make this coefficient positive 1. So I have to factorize out negative 3. Then I can complete squares. Half of this is 2. Then 2 squared is 4. Then open this box bracket, come up with that, rearrange to get that. So in that case, I've completed squares. Then I'll say for the hence part, at the turning point, the squared term should be 0. So when the squared term is 0, it means x is equal to 2. What about y? The whole of this becomes 0, so it becomes 3 minus 5 minus 0, which is 5. Therefore, the coordinate or the turning point is 2, 5. That was part A. Now let's go to part B. Part B says a string of length 60 centimeters is cut into 2 pieces, and each piece is used to form a rectangle. Okay, the first rectangle has width 6 centimeters, and the second rectangle is 3 times as long as it is wide. Given that the width of the second rectangle is x, show that the minimum area which can be enclosed in this way is 96 centimeters squared. Okay, so we shall come and say, 1, let us first make a sketch of the 2 rectangles. So the first one, they said it is 3 times as long as it is wide. So if width is x, length will be 3x. Then they told us that for the small rectangle, okay, for the other rectangle, the width is 6, but they didn't give us the length. That's why I've put an unknown. Then you remember that total length of the string was 60. So when I get perimeter of this plus perimeter of this, I must get 60. Open brackets and could rearrange to get one variable in terms of the other. So here I've chosen to get y in terms of x. Then what about total area? Length times width, which is that. But the good thing, I know the value of, I know y, so I'll substitute for y here and expand to get this. So that is a quadratic. I can now complete squares. So should recall that. But remember that complete squares, this should be positive 1. So let's first see marks for this slide and we go to the next slide and see how to complete squares. So that's how the 9 marks would be got on this slide. Let's see how the remaining 3 marks would be got. So I first factorize out positive 3 to make this quotient positive 1. Then I complete squares. And then I open box bracket and simplify. Then I'll remember that for minimum, the squared term should be 0. So I'll come up with 96, which they wanted. Okay. Then question 13 says, solve each of the following equations from values of theta ranging from negative 90 degrees to positive 90 degrees. So you have A, which is that, B, which is that, C, which is that. So you realize that the range they have given us is for theta. So if it was only theta, the minimum should be this and maximum should be that. But in the question they have given, for example, 2 theta minus 25. So the question is, what should be the minimum angle for this bracket and the maximum angle for that? Same applies to this and also to this. So we need to get our new minimum and maximum. Then we can work with that until we get our theta ranging in that range. So for part A, if theta is this, then I'll come and say that it implies that for this one, the minimum, it means that you substitute this minimum here where there is theta to get the new minimum. Then the maximum, substitute this one here where there is theta to get the new maximum. But not forgetting that the question wants you to solve for theta. We shall see how. Now this is side work. It will not be given any mark. This is side work. It won't be given any mark, but it will be helpful so that you don't write unnecessary angles or you don't write premature angles. We shall see how helpful it is. So let's go to the question. Part A, that's what we're given. It's already in terms of x, cos is already made the subject, so your work is to get the angles. So cos 0.2, you get 78.46. Then remember that cos is positive in the first and fourth quadrants. Okay. Then here we realize that the minimum is negative 205, maximum is 155. So meaning that let me first deal with the positives. Positive ones I'll have from here up to here, which is 78.46. Okay. Then this next positive will be from here up to here. Do you realize that it's already beyond 90? It's already beyond 155. So that one cannot work. Since it can't work, we can now go to negatives. Negative, start from here up to here, which is negative 78.46. Then the next negative will be from here up to here. Do you realize it's already beyond negative 205, meaning it can't work? So we have only those two angles. So that was the purpose of this side work. If you don't have it, you may not know where should you stop. You may just continue writing angles which are outside the range. Okay, now after doing that, next is to look for a way of making theta the subject. Let's first take this 25 this side. So this plus 25, you get this. This plus 25, you get that. And this side will remain with 2 theta. But they want theta, so I'll divide that by 2. So this divided by 2, you get this. This divided by 2, you get that. And basically, that is what they wanted. So I can just rearrange in ascending order and get the 4 marks. Then part B was this. So the first thing to do is to make this one the subject. So I first divide that by 2. Let's see how that is done. So first of all, put here the minimum angle and here the maximum angle to get the new minimum and the new maximum. Then we can start our solution. So divide by 2, you get that. Then arc sine 0.5 is 30, and sine is positive in the first and second quadrant. That is why we are putting those angles here. So remember, the angles must start from the horizontal line. Okay, then we got these ones. How did they come about? Let's see how. One, we know that the new maximum is 308, that is positive, and minimum is negative 222. Okay, so let's see how to get those ones. So the first one is from here up to here, which is this. Okay, the second one is from here up to here, which is this. Okay, now the next positive one would be from here all the way up to here, which is 360 plus 30. That gives you 330, but here the maximum is 318, so that can't work. So we have only 2 positives. Let's go to the negative. Negative, you start from here going this side up to here. That is negative 210. The next negative would be from here up to here, which is 330, but we don't exceed that, so meaning that we can't include that. That is the reason why we have put only these angles. I think we realize how important this side work is. Okay, then you can now make 3 theta the subject by taking this one this side. So 30 minus 48 give this minus 48, this minus 48. Then next is divide by 3. Divide by 3, divide by 3, divide by 3. Then you can arrange in ascending order. And that's what they wanted. So here, seeing all positive angles correct, you get 1 mark. All negative angles correct, you get another mark. Here, all angles should be correct. Then part C, you are given, okay, let's start with side work. Put here the minimum angle, put here the maximum angle to get this as a new minimum, new maximum. Then you can come and quote what was given. You have to make tan theta the subject, so first take this on this side to get this, divide throughout by 10 to get that. So tan is negative in the second and fourth quadrant. So arc tan 0.7, you get this and this. Remember, angles here should be put starting from horizontal line. Okay, now we want to list, you see those angles, let's see how we got them. We are going to start with the positive ones. Positive ones, the first angle is from here up to here, which is 180 minus 34.99, which is this. The second positive angle would be from here up to here, which is 360 minus 34.99, and to be outside this range. So that's why you have only one positive angle. Let's go to the negative angles. Negative angles, the first one is from here up to here, which is this, okay. The second one is from here up to here, which is negative of, in brackets, 180 plus 34.99 to give you this. Then the next negative angle would be from here all the way up to here, which is 360 plus 34.99. But it's negative, so it is that. Then the next would be now from here, you first complete a revolution and then you go back here, which is this. So, and when I think that is the max, because when you proceed, the next will be beyond this. So now you have to make theta the subject. First is to add 200 to each angle to come up with that. Then divide throughout by 5 to get that. Then you arrange in ascending order. And that's what they wanted. Okay. So here it was supposed to be 4. You change it, it should be 4. And that is it. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on Math Paper 2 Marking Guide for end of term 1 year 5. So if you have not yet subscribed, please click on the subscribe button below this video so that I can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so we can all benefit as a family.